Lesson 2-3, solving two-step equations. Our essential question is, how do you solve a two-step equation? We are going to focus on three different two-step equation types. The first type is the most common, and we always see a lot of success with this type. Our goal on all of these two-step equations is the same as it was with one-step equations. Our goal is to isolate the variable, to get the variable all by itself so we can figure out a value that it's equal to. So my first equation says 3x minus 5 equals 7. I'm going to draw my track, and I want you to look at where the variable is. Sometimes it's helpful to even circle it. So my variable is x, and it's attached to a 3. So 3x is my variable part. So looking at that 3x, I can clearly see on the same side with it that there's a minus 5. So just like with one-step equations, I'm going to use inverse operations to take care of that minus 5. So I'm going to add 5 to cancel out the subtracting of 5, like this. And then it's gone. Now I'm going to bring down that 3x, only now it's equal to 7 plus 5, which is 12. Now I've got a one-step equation. I have 3 times x, because the number is right next to the variable, they're multiplied. So I know the inverse of multiplying is dividing, so I'm going to divide each side by 3. So dividing by 3 gives me x equals 12 divided by 3, which is 4. If I plug the 4 in to check this equation, it would work. 3 times 4 is 12. 12 minus 5 is 7. Perfect. You can always check your answers to make sure that you're correct. You do not have to show that you've checked, though. That's just something for those of you who really like to make sure that you've got the correct answer. Okay, my next equation, negative 2x plus 9 equals 13. Same approach. Draw my train track, circle my variable part, and I can clearly see after my negative 2x a plus 9, so that indicates that I need to subtract the 9. The inverse of adding is subtracting. Bring down the negative 2x. Now it equals 4. 13 minus 9 is 4. And then negative 2 times x, they're multiplied together, so I need to divide by negative 2 on both sides. And 4 divided by negative 2 is negative 2 for my answer. My third one, 15 equals 4x plus 3. Same approach again. My variable's on the right-hand side this time, but that's okay. So I circle that variable part, 4x. After it I have plus 3, so I subtract away that 3. 15 minus 3 is 12, so 12 equals 4x. Divide by the 4 that's in front of the x. And 12 divided by 4 is 3, so x equals 3. So all three of these, for the first type of two-step equation, all of these involved adding or subtracting first, and then dividing. This next question is a little bit different, a little bit outside of the box, I guess I would say. Solve this problem. If 5 minus 3x equals 14, so 5 minus 3x equals 14, so they're saying that's true. So if that's true, then what is 2x plus 11? So what we're looking for on a problem like this is, we're looking for a student who is able to understand that this first equation can be solved. It has an equal sign. It's an equation. So this first one we can solve. So we need to figure out what x is. Then we can take that value and plug it in right here. Because 2x plus 11, there's not an equal sign. It's not an equation. So that's just an expression. You can plug in a value for x and simplify it, but you can't solve that one to see what x is equal to. So the first one, I'm going to focus on, here's my variable part, kind of tricky here. My variable part is a negative 3x, and I've got this 5 over here, In order to get rid of this 5, I have to subtract it on both sides, because 5 minus 3x is the same as negative 3x plus 5. The 5 is a positive 5, not a negative 5. So to cancel out the 5, I need to subtract it. Then I can bring down my negative 3x, and it equals 9. Divide by negative 3, and x equals negative 3. Then I take this value up here, and I plug it in. 2 times negative 3 is negative 6, plus 11 is 5. So 2x plus 11 would be equal to 5. So this is definitely a trickier question being asked than just saying solve this equation. Okay, next our second type of two-step equations. So x over 4 minus 1 equals 11. So this type, our variable part is a fraction, After that x over 4, I have minus 1, so I need to add 1 on both sides. Now when I bring this down, x over 4 equals 12. So x is being divided by 4. That means to solve this, I'm going to have to multiply both sides by 4. Remember, when your variable is being divided by something, when it looks like a fraction, it's being divided by something, the inverse of dividing is multiplying. So if I multiply by 4 on both sides, 12 times 4 is 48. The next equation, 7 equals x divided by 3 plus 2. Same approach, circle the variable part. So after that I have a plus 2, so I need to subtract away that 2. So now I have x divided by 3 equals 5, and I would have to multiply by that 3. X was divided by 3, so I multiply by 3. So 3 times 5 is 15, x equals 15. Okay, our last one of these. X divided by negative 2, I circle. So subtract away the 5. 12 minus 5 is 7. X divided by negative 2 equals 7. Be careful on this one. Remember that whatever you are dividing by is what we would have to multiply by. So on this one, we're multiplying by negative 2 on both sides. So 7 times negative 2 is negative 14. Our third type, x minus 5 all divided by 2 equals 3. This one's a little bit trickier because it's a fraction like the last one, but it's a big fraction. So the variable part is actually up here in the numerator, and we need to multiply by the 2 on the bottom of the fraction at our first step. So when it's a big fraction where you've got x adding or subtracting something in the numerator, and then there's a plain number in the denominator, you want to get rid of that denominator first. I think about when you say this out loud, you would say x minus 5 all divided by 2. So it's what you say first, like x minus 5, that's that piece that you're going to leave together for the first step. So that's what I call the variable part. So the x minus 5 is all being divided by 2. So that dividing by 2, it's a little further away. You get rid of that one first. So now x minus 5 equals 3 times 2, which is 6. So now my second step on this one, x minus 5, so I'm going to need to add that 5 to get the x by itself. So then x equals 11 is my final answer. next one. So my variable part is up on the top again, so leave the x plus 9 for now. Multiply by that negative 5 on the bottom of the fraction. Remember, when it's a negative number and you're multiplying or dividing, it's just going to keep whatever sign it had. You're not changing it to the opposite sign when you're multiplying or dividing. So dividing by negative 5, the inverse is multiplying by negative 5. So x plus 9 equals a negative times a negative is a positive. And then keep working to get the variable alone. So now you can subtract that 9, and x equals 26. The last one of these. It's a little bit more complicated again. The variable part on this one, I'm going to stick with the top of the fraction. So I'm going to keep that together, and I'm just going to multiply by 5 at the beginning so that I don't have a fraction anymore. So 2 minus 3x equals 20. Now I want to rethink that variable part. So right now my variable part is only going to be the 3x, the negative 3x part. Remember that 2 minus 3x is the same as negative 3x plus 2. So you can think of that 2 as a positive 2, and you need to subtract it to cancel it out. If you're thinking that you need to add 2 because you see there's a minus sign, 2 plus 2 is 4, not 0. 2 minus 2 is 0. That's why it's gone. 20 minus 2 is 18. Bring down the negative 3x. Don't lose the negative sign now. It's attached to that 3. And then the last step, I would divide by that negative 3 coefficient. So the x is all by itself. So x equals negative 6. Definitely tricky on that last example. There's a lot more going on than in the basic one-step and two-step equations. All right, now switching gears a little bit. Find 3 consecutive integers with a sum of 57. We're not going to write an equation for this. We could write an equation, but I'm not going to write an equation for this. I just want you to think about the vocabulary here. Consecutive means numbers that are right next to each other, like 1, 2, 3, those are consecutive. 7, 8, 9, those are consecutive. And integers means they could be positive or negative. So it might be negative 1, negative 2, negative 3. They have to have a sum of 57, so it's not going to be 3 negative integers if they have to add up, because the word sum means add. So 3 consecutive, so right in a row, 3 consecutive integers that have a sum of 57. 57. So you might just guess and check. You might use a calculator. Your method doesn't really matter. In class, we'll ask for shortcuts, and some kids are able to come up with some good ideas for getting us started. Usually what we'll see is somebody will say, well, if there's 3 numbers, I think I can divide by 3. So if you divide by 3, you get 19. So students start thinking, well, one of the numbers is probably 19. And that is correct. 19 is actually the number that goes in the middle. And these are consecutive integers. So after the 19 would be 20, before it would be the 18. And if you add those together, you do get 57. This next one is a little bit different. So it says 3 consecutive again, but now it says odd integers. Remember that odd integers would be like 1, 3, and then 5 to be consecutive odd integers. And the sum is 117. So sum we're adding has to add up to 117, and they have to all be odd. So if I divide this by 3, because we're looking for 3 consecutive, 3 times 3 is 9. 3 times 9 is 27. So 39 is what I think one of my odd integers is going to be. Here's the deal. If I put it in the middle, The next odd integer would be 41, and the previous odd integer would be 37. If I add those together, that is correct. They add up to 117. Okay, the last one, 3 consecutive odd integers. So again, they're odd. Sometimes they might be, oh, wait a minute, 3 consecutive integers, not even odd. Okay, so I almost started this one out wrong. So we're back to 3 consecutive integers. So that means not the odd ones, but like this. 3 consecutive integers, and this time they have to add up to negative 159. So we have a negative sum. So I am going to divide by 3 again because we need 3 of them. 3 times 5 is 15, and 3 times 3 is 9. So I'm going to put my negative 53 in the middle, because if the sum is a negative, they're all going to be negative for this to work. So negative 53, and they're just consecutive integers, so I'm going to go with negative 54 and negative 52. So if I add those together, that is correct. I get negative 159. So be careful with the reading. Be careful when you're reading these, because I almost made that mistake just because the last one said odd. I assumed this one said odd because I saw another odd number, and it just said consecutive integers. So they might say consecutive integers. They might say consecutive odd integers. They might say consecutive even integers. Be careful with your reading. All right, you should be able to write a summary now. We saw 3 different kinds of two-step equations, and then a couple different things where you were thinking a little differently. So make sure you use complete sentences on your summary, and we always restate the essential question.